Alright, this is screencast 7 bungee jump. The physical principle used is the conservation of energy, and there is the formula for it, or the equation. Here's my knowns and unknowns. I label her mass as 55 kilograms, the gravity constant, field constant, and the height of the jump, and the bungee cord length. And I guess what I was confused on is the value for K. I just plugged in the 20 meters, and I'm really pretty much solving for the distance that the bungee cord is going to stretch, the overall distance. So I set up an initial and a final situation. On my initial, kind of drew my picture, a little stick man, stick woman, whatever, and I labeled my potential initial and kinetic initial. And I labeled my 0 axis here in the initial, and then my final, I have my potential final at 0, and there's my kinetic final that I'm using. The formula I'm plugging in is 1/2 kx squared. And here's the scenario where she's jumping in. I label my 0 axis down here for the final. And here's the equation form, the setup that I did. And for some reason I really don't think I don't want to say it should have been that easy, I guess. It feels like I'm forgetting something because it ran through so fast. So MGH equals 1/2 kx squared. Plugged in my numbers for my MGH, and I took 1/2 squared to this, swung that over, and took the square root of that, and I got 73 meters, almost 73.5 meters. So if I add the 20 meters plus the 73 meters, it's not quite the 100 meters. So manipulating her mass to 63 kilograms instead of the 55 brings that distance, the overall distance of the stretchy cord, going to be at 78.5 meters. Now that should be enough for her to have her birthday wish. I left it in this form because this is my initial, so I just wanted to show you my initial, and manipulating the numbers, this is what I got.